Hey guys, we are going to take a look at 12.4 and talk about infinite geometric series. So keep in mind that a series means we are going to be adding them up. So there's kind of three check boxes that three conditions you have to meet in order to be able to do what we're doing today. One, it has to go to infinity. That's why it's called infinite. Two, it needs to be geometric in nature. Keep in mind that that means it'll have a formula similar to this, where you might have a first term out in front of your ratio to a power. And the power will have your variable n or k or whatever they're using in it. And then lastly, we're going to get a third condition here that we'll talk about in a minute. So an infinite series goes on forever, no surprise. In certain situations, we can find the sum of the terms, or at least a really close estimate. Even though it goes on forever, we can get a pretty good idea of what the total of all the terms would be. But to do so, the series must be, like I just mentioned, geometric. So you're multiplying to get from one, or dividing to get from one term to the next. And your ratio, and notice this is absolute value. So I don't care if it's positive or negative, but the number itself must be less than 1. That's what guarantees that the numbers are getting smaller and smaller and smaller. So I always think of it like a bouncing ball. If I had a ball and I'm bouncing it and it goes half as high, half as high, half as high, and it keeps getting half as high, you would be able to come in and say, hey, you know what? The total of the heights here, if I added all these up, this would be a pretty good answer, because this part after this is so close to 0 that adding it in won't really change what I'm doing. That would be a scenario where your R is less than 1. Your ratio is less than 1. It's getting smaller. If you have a situation where your absolute value of R is greater than 1, now keep in mind, you know R because it's the thing being raised to the power. It's what you're multiplying by. If your R is greater than 1, your numbers are going to get bigger. So you would have something that might go like this, and then double and double and double and double and double and so on. And you can't say, here, let's just add up to here and call it good, because it's not good, because the majority of your stuff is going to be from there on out. So that third condition is that the absolute value of your your ratio has to be less than 1. So the thing getting raised to the power is small enough that you can ignore that very end part. Oops. So this is our new formula, and you're going to see it on your pink sheet. And this is only for when you're going to infinity, which is why it says the sum of an infinite number. All you need to know is the first number in the list, and then on the bottom, 1 minus the ratio. Keeping in mind that if you can do it on your calculator, you would want to have that in parentheses, and that your ratio has to be less than 1. And then if it actually gives you a problem where the ratio is greater than 1 and it goes to infinity, you would say no sum as your answer, because like in this picture, you can't estimate it. It just gets bigger and bigger and bigger. There is no real final answer to how big it gets. So here it says evaluator, find the sum, and this goes from 1 to infinity. So that's my first check, like this is infinite. Secondly, this is geometric because I have n in the power. And so because I have infinite and it's geometric, the next thing I check is my R value. R is going to be the thing raised to the power, so it's 0.8, which is indeed less than 1. I'm good to go. So I can find the sum of an infinite number of terms by taking the first term over 1 minus R. Well, in this problem, the first term is going to be whatever I get when I plug in a 1. And in this problem, the power 1 minus 1 will turn into a power of 0. And anything the 0 power is 1. So my first term is a 5. So that goes in for the 5. Or excuse me, for the first term in my formula. Then on the bottom, I'm going to do 1 minus my R value. And then I just put it into my calculator. And the sum of those infinite number of terms is 25. And what you're saying is, like up here, you're giving it an estimate like I did boxed in here. And the rest of it, even though there's still more answers, is so little teeny tiny that it will just basically not add anything of significance to our 25. Here, I have to actually figure out the ratio. Keep in mind, you can always find the ratio by taking any term divided by the term in front of it. And in this one, I'm getting negative 0.75, or you can think of it as negative 3/4. So my R, if I take the absolute value, is less than 1, so that's a check. If I look and I test it out on my calculator, I am indeed multiplying each one by a negative 3/4, because see how it's going minus, plus, so that always tells you have a negative R. And dot, dot, dot is telling you it's going to go on forever. So I know that I can use my infinite formula. It's geometric, it goes forever, and R is less than 1. So I'm going to need the first term, which I actually don't have to find. I can just copy it. I'm using my formula, A1 over 1 minus R. And I already found my R, and if it's easier, use your R as a decimal. So 1 minus is from the formula, but then my R is also a minus. So you would end up, in this case, adding them together. So I would end up with 1 over 1.75. And my answer would be 4/7 when I do that on my calculator. Here, I see that it's infinite. I can tell it's geometric because I have my variable in the power. And this one's a little tricky, but take a minute to look at this. R is the thing getting raised to the power. And even though that's a fraction, 5/3 is bigger than 1. So this one would keep getting bigger and bigger, and I would have no sum. Here, if I look and see what's going on, I can see it goes to infinity. My R is negative 2, so I can't add this one up either, because if R is negative 2, the absolute value of that is bigger than 1. So these numbers are also getting bigger and bigger, and I would have no sum that was like a good enough estimate. Okay, so word problems. Don't freak out about these. A pendulum, meaning like a thing that swings back and forth, is released and it swings freely. It travels 18 inches on the first swing. So that's your first term. On each successive swing, meaning the next swing, it travels 80%. So that's my R value. It's only going 0.8, which came from 80%. And like always, we have to move the decimal over 2 because it's 80 out of 100. That's what percent means. So it's asking, so like it's saying the pendulum swings and then it comes back at only 80%, and then it comes back 80%, and so on. So it slows down. So it's asking you, what is the total distance that it swings? Well, it swings technically forever. So I need the first term, which they gave me, over 1 minus the R, which they also gave me. And so when you do that on your calculator, it swings back and forth a total of 90 inches. Same setup here. Fred the Flea is on a pendulum having a grand old time. The first swing is 40, so A1 is 40 because it says first swing. And it swings only 75%. So here the ratio is only 75%. And that would, when I think of it as out of 100, I'd end up with 0.75. Oh, excuse me. Even I'm boring myself. Total distance, S sub infinity, because it goes back and forth forever, is a 1 over 1 minus my R. Do that on my calculator, and I get, I'm not sure what, probably 160. I'm going to go with 40 divided by, yeah, it is 160. And that is going to be total distance, and it is measured in something, centimeters. There you go, my friends. That is actually not terrible compared to some of the stuff we've had to learn. A lot more straightforward, I believe. Have a good day.